This is practice 1. In practice 1, we make a VI that load txt file onto the LabVIEW. And in here we need to use this CSV file and then load it into the LabVIEW. In my local drive, I copy and paste under C under temp folder. So this is a C ECG data. And then if you try to open the ECG data with, like, for example, Notepad, let me just use WordPad. And in this one, all the data is separated by this comma. Okay, so we have to specify how each column of data separated by to the LabVIEW later. Okay, so let's just try to make a quick VI using here. And here, if you click on the right button, there's a file IO. So let me try to find the file IO. Here under programming, there's a file IO. And then we have to read the data. So this is a read delimited spreadsheet. So click this one, bring to here. And sometimes some VI has lots of connectors. So if this is too small, maybe you can expand your VI by click on the right button and then unclick view as icon. In a case, you can access each input-output connector a little bit better way. Or even you can expand it. You can even see each kind of label on it. Okay, then I want to first specify what is the delimiter, how each column data is separated by. It was separated by the comma, right? So we click on the right button and create constant and comma. So I need to specify how the column data are separated by, and the file path is there. So I moved a mouse cursor, click the right button, and let's create the control. So when you create the control, you can specify your folder. Okay. So in here, you can specify the folder after you run the button, or maybe you can even click right now, and then I go to where I saved the file, so C and under temp, and then this ECG data set. So I just specify it by clicking this one. Okay, and after that, I want to dump every red data set into the array. So this is all rows, and click on the right button and create indicator. So these are all the array that you will see the data sets after you load the file. So let's try to run. Now I see that all the 4 column data are successfully read. So it seems like the first column is the timestamp, and second and third and fourth is voltage. The voltage changes from 3 different channels. Okay, then I think this is pretty much practice 1. And then, okay, so we have to make a plot as well. So plot the waveform, time versus voltage. So let's try to make a plot one of the voltage. So we have a channel. Let's say this is channel 1, and this is channel 2 data set. Okay, and this is channel 3. Then let's try to make this channel 1 voltage versus time. So to do that, we have to extract the first and second column from this whole row. So you have to go to the array, and then index array. So you have to take the first and second column. So I want to use the index array, and then click this one to this one, and then I want to select the first row, first column, which is index number 0 for column. So I just put a 0, and this is my time. So I just make another column, another array, for example. Then this should be your time array. And likewise, if you just copy and paste this one, and you can just tap the wire from the red file, and then the second column is index number 1, and then this one should be your channel 1 data. So this is a channel 1. So if you run it now, this time is the same as the first row, and the second one, this channel 1, is actually from your channel 1 data set. So from there, we can make a simple scatter plot. So in the scatter plot, we have to go to graph and XY graphs. Okay, XY graphs. And this is my XY graphs. And then we have to bundle them to make an XY graph. So go to the cluster, and then there's a bundle here. And then I just connect this one, my X is my time, and the channel 1 voltage is my Y, and connect this one to XY graphs, and let's run one more time. So now I see that the voltage fluctuating, so this is the ECG voltage change over the time, over the 5 seconds. Practice 2, we are going to use the same file, but at this time this is more about how we manipulate the red file. So let's make a plot, time versus channel 1 plus channel 3 signal. So this is a lead 1, lead 3. So when you measure the ECG, instead of channel, we used the word lead. So anyway, so lead 1, lead 3 voltage is added, and then plot time, lead 2 signal on the same XY graphs. So first we have to add channel 1 plus channel 3 signal, and then make a plot, and then on top of it we just make another plot, time versus lead 2. So we are going to use the same the file reading technique, so we don't need to change this one. And however, we have to add channel 1 and channel 3. So in here we just manipulate our data set. So this is channel 1, so I want to make another index array, and channel 3, in order to access channel 3, your index number is 0, 1, 2, 2, 3. This is 3. Our first column is a 0 and 1, 2, 3. And this is a channel 3. Right? This is channel 3 data. And I want to add channel 1 and channel 2. So go to the numeric and add. You can add the array. Okay. This is array. So this is channel 1, channel 3. So this output is basically channel 1 plus channel 3. And then we need to access channel 2 as well. So I just copy an index array one more time and tap the wire from there. This is index number channel 2. This is channel 2 output. So this is channel 2. Okay, then we just make up another plot. So let me create another graphs, XY graphs. And then we have to make a plot time versus channel 1 plus channel 3. So let's just copy bundle on here. Okay. And our axis is still time, so that's the same as from the time. I have to tap the wire from the time. So let me just tap the wire time from there. So this is time. And then our y, our y is from channel 1 plus channel 3. So this is channel 1 plus channel 3. So if you run, you can see that this is a channel 1 plus channel 3 signal. Okay. And then the next one is I need to make another bundle. So because I need to make a time versus channel 2, so the x-axis is a time, this is time, and this is channel 2. Then you have to, in order to make multiple line on the XY graphs, for some reason we have to bundle these two output as well. So let me just disconnect this one temporarily and then try to make another like a bundle, because we want to display the two different lines. So let me try to bundle these two lines and then put together into the XY. Oh, I have error. So this one, instead of the bundle of bundle, let me delete the broken line. We have to use the array, and then we have to use the build array. Okay? This is build array. So this is a build array. So you can just expand this one. So this is one input. This is a second input, and then you can just connect XY plot. Then because we have a two line, let me expand this one into two. So this is channel 1, channel 3 signal, which is plot 0. Channel 2 signal is plot 1. Let me run. So now you can see that channel 1, the first channel is a white color. Channel 2, second one, plot 1 is the red color. So if I change my plot type a little bit differently, then I can just put the dot for my second plot. So I think this making the multiple line onto XY graphs, you have to use this kind of the build array to collect the multiple line. But when you make a scatter plot, please remember you have to use the bundle. In practice 3, we are going to learn how to store the data into file. In practice 1 and 2, we learn how to read the file from txt file, and however in this practice 3, we are going to use random generator, and then we just consider it as like per temperature values. Then in order to scale up the random variable, we just multiply 100, and then we try to record that data into a file after we exit this program. In this program, let's say we want to record the temperature data for 5 seconds. That's why there's a one duration control. So after 5 seconds, it automatically exit the program, and all the temperature variable generated by random variable will be stored into a file. In here, Let's make numeric control that set the duration, and after that we have a, for example, let's say put the thermometer like indicator. So maybe we can say the vertical progress bar. Let's just use this one as thermometer. Let's say this is thermometer. And then we want to create, we just mimic that, kind of simulate the thermometer value using the random variable number. So I want to find the random variable generator. And in order to make the variable more realistic, let's just multiply 100 so that it more looks like a temperature value. And then we just show it. Okay. Now if you kind of run, and maybe this random generator just generates and then it shows the this kind of bar. Okay. But in order to make a program that we record this one for a specific time, then let's try to make a while loop and then just encompass everything here. And then also, whenever this one generates a variable, we want to store it into the memory temporarily, and then after we exit this while loop, we want to store into the file. Okay. So in order to do that, let me make a shift to register. Okay, shift to register, and I want to add every variable into the data set like array, and after this while loop exit, all the stored data as an array will be passing this line, and then we can store into the file. Okay. So in here, in order to stack this one to the array, we have to use the build array. So array and then build array, and then expand this one to 2D, and then this new element goes to the second node, and then first one came from the previous iteration. Okay. And then initially I want to set this one as empty array. And after that, this while loop iterates so fast, so I want to just iterate at every maybe 500 milliseconds. So let's put the timing and the wait function here. Okay? This is wait function in about 500 milliseconds. So which means at every 5 milliseconds, this random generator generate the number and store into the memory. And after that, I want to connect this one to go to the file IO. At this time, I want to write. You have to write the array into the file. So this is write, and click this one, and then if you look at this input connector, there's a 2D array and 1D array. So right now this is just 1D array because you stack the scalar value to the stack of elements which becomes 1D array. So you can just connect this one to 1D array like that. And after that, I want to specify the file name. So this is file path. So I click this one and then click control. So when you use this one as control, now we can specify some file name on here. So let me specify the file first. So let's say under C under temp I want to make any like file name, let's say output data, output txt, then which means under C under temp all those kind of the generated value will be stored into output txt file. Okay, so I think we're almost done, except how we can make this while loop stop over a specific period of time. So let's say I want to put the 5 seconds, then after 5 seconds I want to automatically exit this while loop, then every data that has been created for over the 5 seconds will be stored into this file. So in order to do that, I just read how much time have elapsed since I started the while loop. If the elapsed time is greater than 5, then I can connect that into this stopping condition here. So whenever something is true, then it will stop the while loop. So in order to read elapsed time, let me move this one to top. Elapsed time, we have to read the current time. Whenever the while loop iterates, you just read what is the current CPU time. You can go to the timing and then you can tick count. This is a read time as a millisecond. Okay. And then in order to see the elapsed time, you have to read the time right before you start the while loop, right? So this tick time should be placed outside the while loop as well. Okay. So once you go into the while loop, this one and that outer tick time should be compared. So I just put the numeric and subtract. So I subtract the current tick time. I subtract the right before the tick time, right before you executing the while loop from the current tick time. This is elapsed time. So this is elapsed. And then this elapsed time is a millisecond. So in order to convert to the second, you have to multiply 1000, right? So you can just multiply 1000. So this is actually elapsed time as a second. So if this is greater than this duration time, okay, then you can exit this while loop, right? So this is duration time. So you can compare. I just compare if this elapsed time is greater than the current time, the set time duration, then you can exit this one. Okay? So this is pretty simple logic to compute elapsed time and make it to condition. Okay, then we are pretty much done. So let's try to run. So I'm going to run only the 3 seconds. Okay. So over the 3 seconds, let's see. My mistake is that in order to convert the millisecond to second, this one's supposed to be division, not multiplications. Okay. So let me just replace this one to the divide. So I have to divide to make a second. So now I can compare the second to second. So let's run. So this is just a random number, and after 3 seconds it just stops. So all those kind of random number generated variable are stored to this output txt file. So let me double check whether I can access that file. So under temp, I see this output file. So if I click then all those kind of randomly generated temperature value are stored. So 1, 2, 3, 4, 5, 6, 7. In practice 4, we create a sub-VI that takes an array, computes its mean and RMS, root mean square, and provide the answer. Okay, before we think about the sub-VI, let's create a VI that computes the mean and RMS from the array. So, for example, let's say I want to make array first. So this is array. So I just pushing this one inside, and then let's say we have any random number. Okay. I just make up any number. So we made this kind of random kind of array. Then I want to get the mean and then root mean square error. So how do you compute the mean? You can just add them up and then just divide by the number of elements. But in the LabVIEW, we have a mean function. Okay, so search the mean, and there's a mean VI here. So this is mean under probability statistics. So I just bring this one, and then you can easily get the mean value. So this is the mean. And how about the RMS? RMS is you have to square each one of them and add them up, and then take the square root. That's the RMS. So then you have to just square them. So I go to numeric, and then there's a square. Let me see. There's a square of them. There's a square. So I want to just square each element. Okay. So these are all each elements. And then you have to add all the elements. So if you go to the numeric, and I think there's all the sum of add array element here, right? This is add array elements. So let me show you the label. This is add array elements. You just add them up, and after that you take a square roots. So we go to numeric, and this is square roots. So this is RMS, right? This is RMS. So root mean square. Root mean square value. So basically this is mean, and this is RMS, and this is input. So let me run, see whether we can get the correct value. Okay, now after that, let's save this VI. So I want to save this VI, and then I want to use this VI as a sub VI for other programming VI. So go to File and then Save. Let me just try to save as. I want to save under C under temp. So let's say this is calculate mean and RMS. I just saved it. This file. I saved it. And then if you move your mouse cursor, you see those kind of patterns, some pattern here. So if you click the right button, then if you look at the pattern, I want to do I want to create the connectors for input and outputs. In order to use this VI as a modular VI or sub VI for other VI, I need to connect the wire to the input of array and two wire for mean and RMS value. So this one has a one input, which is array, two outputs. So in this pattern, maybe we can just use simple as simple as this pattern. We don't need so many input and output connectors, so I just choose this 4 block. And then in order to associate any control with this kind of connector, click one of the box and then click your control. Now your array is now associated with this connector. And then for the output, click on another kind of block and click the mean, and I click another block for RMS as well. So now this mean and RMS are associated with these two output connector. Okay? And then you can even design your sub VI. So if you click on the right button for this design, there's an edit icon. So you can design even this kind of sub VI icon as well. But let me skip part here today. Okay, after that you saved it again. I saved it. Okay, now let's open a new the VI. Okay, I open up the new VI because I want to use the sub VI from my program here. Okay, so this is a new VI. Then we already created the sub VI, but let me show you how to utilize the sub VI from other VI. So for example, in here, let's say we have like another array, okay? And then this array has a different data set. So let's say 1, 2, 3, 4, 5, and 6. I want to get the mean and RMS of this array. Then because we already made that sub VI, you can just easily just call out that sub VI. Okay. So how can you access sub VI from here? Move your mouse cursor to the block diagram, click the right button, and then if you go down there, there's a select VI. Okay. There's a select VI, and click the select VI. Then you can just click your sub VI. So I want to call this sub VI, then just place it over there. And on the left side is array input. So I just connect this one to my array input, and on the right side this is mean, this is RMS. So I just create indicator, this is a mean, create another indicator for RMS value. And then run. So now we can get the mean and we can get the RMS. So this sub VI serve as like a function. Okay, the sub VI in the MATLAB is the same as a function in any other programming languages. And this is assignment. And in this assignment, we make a VI that reads one TXT file, which is LV data TXT file. If you open the LV TXT file, it has a 3 column, time and Y1, Y2 values. And this Y1, Y2 values is sine and cosine functions. And after that, we make a plot for Y1, Y2 versus time. So in this example, you see that blue and red color of signals over the time. Then we just manipulate our data so that we create another data sets, another data called output data by comparing two input value. If y1 are greater than or equal to y2, our output value is 1, otherwise or 0. That's why this black line is our desired output. So basically comparing y1, y2, and if y1 is greater than y2, we just set all the 1, otherwise 0. So we can kind of make a digital output signals. After that, we plot everything all together at y1, y2, our desired output. And finally, it writes a TXT file that contains only two data sets, time and the outputs. So that's the assignment 1. So you can download and save under your local folder. So in my case, I saved under temp under C LV data here. Okay. Okay. So now let's begin programming. So let me make a block diagram is a little bit bigger. So first, I want to read the file. So you have to go to File IO and read. So I want to read the file. And then where's the file path? So in the file path, I move the file path and click the right button and Control. So in here, let me specify which file I want to read out. So this is LV data TXT. And then just make sure that there's any delimiter. So in here, let me double check whether this one is how the column are separated each other. Let me use this one. So when I look at this one, all the column are separated by kind of blank here. So my delimiter should be the blank. Okay. So in here, and then where's the delimiter? So this is let me make this one is a little bit bigger so that I can see all the input connected better. So this is delimiter. I constant, and I manually type one blank. So I just type. I just pushing the space bar. So this has a one blank. Okay. And after that, I want to read all the raw data sets. So let me make this one is a little bit smaller again. And then all the data set is a 2D data sets. So let me just make all the row in the array and see whether we can successfully load or read all the file. So now something is not correct. So the dummy zeros are kind of inserted into my file. So let me figure it out why this happened here. Now I realized that this LV data sets, this is separated by, this is actually separated by, not the blank, separated by the tab. It's not, it was not a blank, it was a tab. So by default, so when you take when you just do the delimiter, let me just expand this one more time. So when you make a delimiter, the tab is by default. Okay, so we don't need to connect anything to the delimiter connector here. So we just read it. Okay, if you just read it, now we read the first and second and third column. and the first column is just a dummy. I don't know why the first column was also read as all the zeros, but anyway, so first column is time, and this is y1, y2. Okay. So now it seems like everything is read successfully. Then after that, we have to we already done that. We have to make a new data set output by comparing two input data. Okay, so in order to do that, we have to compare the y1, y2 at each iterations. Then we just create the number. So in order to do that, I want to know, I want to just take all the elements, so which means my logic is that we use the for loop, and then we just look at each data set and then just compare them. So go to the structure and then for loop. Okay, this is for loop. And then we can just sending this all the 2D array into this for loop, and this is auto indexing, so which means when you just passing through this one, inside here we can access each row. Okay, each row. Then we want to compare y1 and y2 only. So once we can kind of pass only the each row, and second column and third column is y1, y2. So I want to access each y1, y2. So I want to use the array index. And then if I just make another copy of index number, so for example, and the first, once you passing the first row, the first column should be time. This is time. This is output is time. And then if the column index number is 1, this is y1. And the column number index number is 2, this is y2. Okay. And then we compare y1, y2. So let's put the comparisons. If y2 is greater than equal. So if y1 value are greater than equal to y2 value, we set the 1. So y1 is greater than equal to y2, then we put the 1. Okay. Then we have to create a case structure. Oh, if this is true, I want to put the number 1. So I want to go numeric constant. This is 1. Otherwise, this is false. Then I want to put the 0. So this is a 0. And connect this one to here, and then connect this one to there. And then because we have to create this output file that has as many as the number of elements of y1, I want to use the build array. So first make a shift register, and then make array build array. And this new element goes to the second part, and your previous one goes from the previous array. Then I want to start from empty array. So in the empty array, I just, as we create either 1 or 0, we just keep adding into that array to get the new output here. Okay. So this is output. So can we me quickly run and see whether we can get the correct answer or not. So let me make this one is reduced. This is output. So let's run. So it seems like our output has 0 or 1, so it seems like it's working. We just compare y1, y2 value, and we just add all the 1. Okay. So, and after that, it plots all input and output data series in the charts. Okay. So we want to plot all y1, y2 output at the same time over the time. Okay, then make XY graphs. So this is XY graphs here, and XY graphs should be outside. Then in order to make 3 line, first think about the first line, which is time versus y1, time versus y2, and so on. Okay, so that one we can just take all the time and y1 information from this original output file. Okay, so let me make this one is a little bit more neat so that we have more space, and make this one is clean wire. So in order to make a time versus y1, I want to take from here. So I want to make an index array from this original red file, and then I want to take only the first column, right? This is a row and this is deserved index column. So in the column I put the index number 0, so which means this is my time. So this is time column. And likewise, if I change my index number 1, everything is the same. This is a y1. Okay. So after that, we just make a bundle. Okay. So in order to make a scatter plot, we just make a bundle, and my time goes to x, and my y1 goes to y-axis, and this is xy graphs. But let me hold it. I want to make another bundle for time versus y2. So in here I just copy this one, and this is 2, and this is y2, and then another bundle. So my x is the same as time, same as time, and my y is y2. This is y2. Okay. And after that, how about the time versus output? So this is output file. This is output file. So we can just make another bundle. So time is the same as from there, and this is output, which is a digitized value. So I just bring this one to there. Then we can make a 3 kind of bundle, and then these are 3 independent line, right? And then in order to show all the 3 line onto the same plot, we use the array and a build array. This is a build array, 1 to 3. So you can expand your build array 3, and then just combine everything here, 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 and then XY graphs, and then let me make this one is plot 0, 1, 2, and my plot 0 should be y1, and plot 1 should be y2, and plot 2 should be output. So run. Now we see that y1, y2 as a sine cosine function, and our digitized output, which is the green line, shows the either 1 or 0. Okay? Okay, after that, we write a txt file that contains only two data series, time and outputs. So now as a file, we want to save a file that contains time information and only the output information. So in this one, we have a time. This is actually this line is all the time information. This is output information. So I think the easiest way is that we use the we want to combine time array and output array together, make a 2D array and save it, okay, as a file. So in order to do that, we do the build array. I want to connect the time array and then this output array. This is our output, and this is a build array. And then you go to file IO, and then I want to write our data into file. So this one should be 2D array. I connect this to 2D. Where do you want to save it? So go to file path and create control. So in here, I want to click, and then here assignment output txt. Okay. I want to save this file, and then let's run. Now everything just runs successfully, and if I checked my folder, I see this assignment output. So let me open up here. Right now, if you open up here, it seems like the time goes to my first row, and then all the output goes to my second row. Maybe you can just leave it as it is, but usually when you make a two-dimensional array, my first column should be time and second column should be my data set. So probably you may want to transpose this one even before you save it to a file. So in here, I want to transpose first, and then I want to transpose it and then save it. Okay. If in this kind of write VI, there's a transpose function here. So you want to transpose it or not. So by default is no. Okay. But if you want to transpose it, you can connect to here as a false, a true. So just move your mouse cursor to transpose it and then right click and create constant and make this one is true. Then you can actually transpose it and then save it. So let me run one more time and check your up file. Now this is transposed. So your first column is time and second column is output, either 0 or 1.